Amplitude and period, let's get after it. Already talked about amplitude. We got that thing, huh? Right here. For these equations, y equals a sine x bx minus c. Y equals a cosine bx minus c. Notice we're taking the d part out, the vertical shift. Let's just kind of ignore that piece for now. I don't do too much work with it, nor will you need to do it in your homework. Just understand the concept. However, amplitude and the period are huge. So our amplitude is just the absolute value of whatever the a value is. So like the one down there, that's 7. And the period of our function, the period is just going to be 2 pi divided by whatever our b value is. And for the one we have down there, it's 3. So we'd have 2 pi over 3. That's going to be the period of the function. Let's go. Now, I'm going to draw cosine in. I'm just going to draw it in just the parent function. And until we get to the phase shift, you can always do this. If you ever wanted to graph it, you can just draw the basic shape. All right, this would be cosine. I haven't put my x values in. The x values actually are the most important thing when I think about it, is to knowing where things are, so how things are going to be shifted and moved around. So for this case, I'm actually going to take all of this out and I'm going to write it in. Be like, that's pi over 2. This one's pi. This one's 3 pi over 2. And then once we get to here, that's going to be 2 pi. Okay. And that's just for our parent function, y is equal to cosine of that. But now, let's go through and let's graph this one. Now I'm just going to change and show you how. I'm going to change the amplitudes on it. I'm going to call it 7 and -7. Now my amplitude is perfect from here. It's equal to 7. Wonderful, change my scale. But now we look and we say, well, our b is equal to 3. That's your b. And we want to know that we use this to get the period. So 2 pi divided by whatever b is. So we get 2 pi over 3. Now what that does is it tells us that it no longer takes us 2 pi to do one full period. It's saying it's now been cut into thirds. Now watch. Want to see a quick trick you could do to all of your x values? Divide them all by 3. Divide them all by 3. And now you can have a quick, easy graph. You have a quick, easy graph. So now we're saying like, whoa, what's pi over 6? So pi over 6, then pi over 3, then the 3's just cancel out right there. And we get what? What? Just pi over 2? All the way up to 2 pi over 3? What? So this is actually this number here, 4 pi over 6. This one's 0. This number there, you get pi over 6. You get 2 pi over 6. And you get 3 pi over 6. All gaps of pi over 6. Weird. It's these little, we call these tick marks. These are tick marks. There's 5 tick marks we always want to have when we're graphing so we can see what the period is. So we've just changed our graph. Just by taking, if we know how to graph our parent function there, we could just take our b value and then just go and divide all those little parent function x values. Weird. Weird, but notice this is 2 pi over 3. That happens 3 times faster. 3 times faster than our actual graph. Like our graph, the parent function, like on top of it, if we were just looking at 7 cosine of x, we'd be more like this. It'd take longer, right? It'd take actually, the distance would have to be 3 times. Mine's not to scale, but it would be like, this would be 1, and then there'd be like another 1, and then there'd be an even 3 gap. So it'd be 3 times as long. Of course, my shit's not to scale. Ooh, shoot. Yeah, so there's that piece. Now let's just get into this. Like, I'm looking at your homework problems. Let's jump into it. I'm probably going to get you some other. I'm going to send you some links to some real graphing, so you don't have to necessarily just watch me do all this stuff. So let's try this one. Y is equal to negative. I like 17. I don't know what it is. Sine of, and let's go pi over 3 times x. And I ask you, what's the amplitude? And what's the period? And this is like straight homework stuff. Straight homework. Well, the amplitude is just the absolute value of whatever this number is. So our answer is, our A is just 17. Cool. Well, the period is found. The period is equal to 2 pi divided by whatever number is attached to x. So we pop that in, we get pi over 3. We'll go old school if you don't remember how to do this. This is 2 pi divided by pi over 3. 2 pi times 3 over pi, and we're like, those go away, and we get 6. So the period would be 6. So that would mean sine, to go all the way to here, it would be 6 radians to get there. 3 radians to go halfway, and 1.5 radians to go there, 4.5 to go there. But my graph's wrong. Shoot, I was trying to show you something simple. But while the amplitude is a positive frickin' number, there's a frickin' negative right here, which means that we're going to reflect ours across the x-axis, which means sine will start by going down, not up. It'll take it 6 units, its period, to do one full period or one full cycle, but since we have a negative on our value there, we start by going down. And that's a reflection across the x-axis. Another one. Let's go. Y is equal to 14 cosine of x over... stop writing 17. Stop it. Stop it. Let's call it 5. Again, we want to know what's the amplitude. Hey, let's just write it down. 14. Amplitude's dope. It's dope. It's no big deal. And now we want to go find that period. And now this is kind of one of the ways we can trick you a little bit. We're like, all right, the period is equal to 2 pi over. And a lot of people want to write 5. I'm like, nah, dude. Nah, dude. Dividing by 5 is the same thing as multiplying by 1/5. So this is 1/5 times x. And the sooner you can grasp this, that these are the same things, oh my gosh, math is going to... Like, there's just little things where math's going to get so much simpler. So much. So just see that. Dividing by 5 is the same thing as multiplying by 1/5. Because I don't know about you, but I like multiplying a hell of a lot more than I like dividing. So our b value is 1/5. So again, we go into here and we're like 2 pi divided by our b value, 1/5. Go old school if you need to and say that's 2 pi divided by 1/5. Now we can see it's just 2 pi times 5, which is equal to 10 pi. And that's the period of this function. So you have a few homework problems in it where it's just straight up asking you, like, what's the amplitude and what's the frickin' period of the function? And that's how we're going to find the amplitude and the period of the function. Do you notice that since we're dividing this thing by 5, multiplying by 1/5, cutting it, making it just 1/5 as big, the same thing as dividing by 5, it's actually taking it 5 times longer to complete this period? It's 5 times longer, not 2 pi, but 10 pi now, because it's only moving 1/5 as fast through. We're back here, where we had pi over 3. That's like 1 point something. So it's saying it's speeding it up by a little bit. 2 pi, by the way, is approximately 6.28. So 6.6 is just a little bit of a stretch. That's not a very good example. I don't like giving you negative numbers in here, though. So just expect that b will be a positive number each time we do this. I don't like to deal with the negatives inside of there. There is some other things we can do with it, and I'm not saying that we can't. I'm just saying I choose not to. Okay, so let's call it 1.6 times cosine of, and now let's call it 3 pi x over 4. Last one. Real quickly, amplitude, just call it 1.6. That thing's positive, so that means we'll be starting up top at 1.6 and then traveling down and doing some other bullshit. Where we got our negative 1.6. Cool. Now we go get our period, and our period is going to be 2 pi divided by the number that's written there, and that's 1.6 times cosine of 3 pi over 4 times x. Get all the numbers away from the frickin' x. The x goes up top, therefore we put the 3 pi over 4 here, which ends up being 4 times 2 pi over 3 pi. I'm not showing that step because I've shown it enough times. And that gives you 8 over 3. So it would take it, that number here would be 8 over over 3 for it to do one full frickin' period. Here's amplitude and period. More shit later.